Hi, everybody. Um, this is going to be a lesson on equivalent fractions. I know that we've done some lessons over the past few weeks on Khan Academy about equivalent fractions. So I thought that we would do a little bit of review and take a look at those because hopefully you've had some time over spring break to relax. So equivalent fractions show the same amount of something, okay? It might just be in different size pieces. So what I mean by that, let's take a look at a model. I'm going to draw two rectangles that I'm going to try and make them the same shape and size, okay? And we can say, if we take a look here and shade in this first rectangle, we can say that that is 1/2 of the rectangle that's shaded in. We have two pieces, one of them are shaded, so that is 1/2. If we shade in the same amount, okay, over here in the bottom rectangle, you can see that we have 1, 2, 3, 4 equal pieces, and 2 of those are shaded in. So although these fractions have different numbers, different digits in them, they are showing the same amount of the whole, okay? So we can show that by looking at a picture, but we can also think about that using math, using what we know with our basic facts. We can say 1/2 is equal to 2/4. And how do we know that? Well, we can look at what we had to do to 1 to get to 2, and what we have to do to 2 to get to 4. And if it's the same thing, if it's the same number that we're multiplying by, then we know that they're equivalent fractions. For example, 1 times 2 equals 2, and 2 times 2 equals 4. So we know that because we can multiply this numerator and this denominator by 2, and we end up with this numerator and this denominator, that we have equivalent fractions. So let's take another look at an example. Okay, let's take the fraction 2/3, and we want to create an equivalent fraction to 2/3. If they don't give you a fraction, if they're not asking you for one, they just want you to make one, okay, then you can multiply 2/3 by any whole number that's a fraction. So I could do 5/5. We know that 5/5 is equal to 1 whole because anytime the numerator and the denominator are the same, it's equal to 1. So I can multiply 2 by 5 and get 10, and 3 by 5 and get 15. And then I can say that 2/3 is equal to 10/15. They're the same amount. I could also, you might see a problem that looks like this. It might say 3/4 is equal to how many twelfths? Okay, so that's what they want to know is, if I take 3/4, I want to create a fraction that's equivalent, but I want it to be in twelfths or 12 pieces. So we could say, well, what would I multiply 4 by? What number would I be multiplying 4 by to get 12? And the answer there is 3. So if I do that to the bottom, I need to do the same thing to the top. And 3 times 3 is 9. So 3/4 would be equivalent to 9/12. We could also look at that as a picture. I could say, okay, hopefully you would all agree that that is 3/4, okay? And if I wanted to show you or prove to you that it was also equal to 9/12, I could take this whole rectangle and split it into 12 equal pieces instead. So I could do this. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, and 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are shaded. So I just proved that 9/12 is equal to 3/4. It's the same amount. We just split it up into smaller pieces. I didn't change how much was shaded, and I didn't change the size of this rectangle, okay? Now, another thing that they talked about on Khan Academy was reducing or simplifying fractions. So if you hear this word simplify or reduce, okay, what that means is sometimes it's harder to visualize larger fractions. Even things like 9/12. We might not be able to think in our head what that looks like. Or to split up, if I asked you to split up this whiteboard into 12 equal pieces and shade in 9 of them, it's hard sometimes for our brain to really picture that. So if we simplify fractions or make them into the largest chunks that we can, it's easier for us to visualize that. So like 3/4, I can think about 4 things or one thing split into 4 pieces and taking 3 of them and go, oh, okay, well that's a good amount of whatever it is that I'm splitting up. So simplifying fractions just helps our brain make sense of those fractions a little bit easier. So let's take a look at how we can do that visually and how we can do that with calculation, with math. So for example, if we have something like, let's just go 4/8. Okay, I want to show 4/8. So I could create a model here. Okay, that has 8 pieces. And I can shade in 4 of them. And you can see from my picture that I have a hole here that has 8 equal pieces, and I've shaded in 4 of them, or I've created the fraction 4/8. But if I think about making this a simpler fraction for my brain, something that's a little bit more familiar for me to understand, I can see also that I have half of this square filled in. So I could say 4/8 is equal to 1/2. So I could do that by looking at the picture and trying to split it up into bigger pieces. So I've kind of tried to ignore these middle parts and just look at these 2 big pieces for my square. Now, I could do this in a mathematical way. I could take 4/8 and I could divide 4 and 8 by something to get my equivalent fraction. So I've got to think though, now I've got to think about my math facts, my multiplication facts, or my division facts. They're kind of the same, right? You got to think about them backwards and forwards. If I think about something that I can divide 4 by, that I can also divide 8 by, well, they're both even numbers, so I can divide both of these by 2. So I could divide 4 by 2, and I could divide 8 by 2. And 4 divided by 2, or 2 times what equals 4, is 2. 8 divided by 2, or 2 times what equals 8, is 4. So this might be an easier fraction for us to understand, 2/4, but if I look up here, I ended up getting 1/2. So then I can look at 2/4 and go, well, wait a minute, 2 is an even number and 4 is an even number. So I can divide 2 by 2 and I can divide 4 by 2. So dividing 2 by 2 and dividing 4 by 2, and I get 1/2. Or I could have come all the way back here to the beginning and said, if I know my facts pretty well, okay, I could think about, well, I can divide 4 by 4 and I can divide 8 by 4. And when I do that, 4 divided by 4 is 1, and 8 divided by 4 is 2. And I end up with 1/2. Let's take a look at another one of those. This is where knowing your multiplication facts really comes in handy. You'll be working a lot with fractions in middle school, and the more that you can see those patterns and those relationships with numbers, just the easier doing simplification is going to be. So let's take a look at a number like 10/25, a fraction 10/25. That's kind of hard for our brain to think about. I would have a hard time if I looked at like a chocolate bar and I had to split it up into 25 pieces and shade in or break off 10 of them. That would be hard for me to kind of visualize in my head. So simplifying fractions, we could think about, if I count by a number, do I land on 10 and do I land on 25? Well, if I count by 2s, I land on 10, but I don't land on 25. So 2 isn't going to work as a number we could divide these by. So then I could think about 3s. Well, that's not going to work for either of these numbers. If I count by 3s, I don't land on 10 or 25. I could think about 4s. That's not going to work. But if I think about counting by my 5s, I know that if I count by 5s, 5, 10, 15, 20, 25, 30, I'm going to land on both of these numbers. So I can divide both 10 and 25 by 5. So 10 divided by 5 and 25 divided by 5. If you're not real comfortable with your division facts, you can flip these around in your head. You can think, well, 5 times what equals 25? And our answer there is 5. And 5 times what equals 10? And our answer there is 2. So we end up with 2/5. 10 25ths is equal to 2/5. And that's a little bit easier for my brain to make sense of. I could look at a candy bar and I could split it up into 5 equal pieces and take 2 of them. I could do that a lot easier than I could do splitting it up into 25 pieces and taking 10 of them. So I hope this helps make sense a little bit more of finding equivalent fractions and doing a simplification of those.